systems of linear inequalities. We've looked at linear equations, chapter 5, lots of linear equations. We've looked at systems of linear equations, most of the first half of chapter 6. And we just finished looking at linear inequalities. Of course, the next obvious step, or the next progression, would be systems of linear inequalities. Two inequalities at the same time, and we're going to look at what happens when you combine them together here. So, we're just going to test. Part of this is just testing. Is 4, 5 a solution to this system of linear inequalities? Let's try it. So again, I've got an x. Oops. Sorry, I've got an x. I've got a y. I'm going to substitute in. The first one would be 5 less than or equal to 4 plus 2. The second one would be 5 greater than or equal to 4 minus 1. We really only need to test them one at a time. If the first one doesn't work, then it doesn't matter. So let's test the first one. 5 less than or equal to 6. Is that true? Yeah, 5 is less than 6. We're good. Try the next one then. 4 minus 1 is 3. Is 3 less than or equal to 5? Yep, 5 is greater than or equal to 3, so it works. So they will not necessarily be equal to each other. In fact, they probably won't be the exact same number, but we have to look at that inequality and say that 5 is less than 6, 5 is greater than 3. Yes, so this would be a solution to that system of linear inequalities. Graphing. Now the good stuff. So we're going to solve this system. We're going to figure out what are all the possible solutions to both the first inequality and the second inequality. And there's really only one way to do this, and that's by graphing. Solving it by substitution, elimination really doesn't work all that well. Sort of, kind of, but not really. So, graphing. We've got y by itself. That's essential. Y equals mx plus b. For the first one, I'm going to use blue. So for the first one here, we've got a y-intercept of 1. All right, y-intercept of 1. There we go. And we've got a slope of 1 over 1. Rise over run, so rise over run. I've got my equation here. I've got my graph. There we go. It says y is greater than or equal to, so I have a solid line. And it says y is greater than x plus 1. So y is above the line. Y is greater than the line. So I'm going to shade everything above the line. Now, you don't have multiple colors. I have multiple colors. You could certainly use your own multiple colors, and that would be great. But if you don't have multiple colors, I suggest making lines like this, and you'll see why in a minute. So if you just do some scribbles like we were doing before, it works better if you use lines like this, and you'll see why. All right, unless you have different colors, then it's just gravy. Y is less than or equal to negative 2x. Again, there's no y-intercept plus 0, so the y-intercept would be 0. There we go. Slope, negative 2 over 1. So we go down 2 over 1, down 2 over 1. And I'm going to connect dots there. Again, it's y is less than or equal to, so I do have a solid line. And y is less than the line. So every y value that's below the line will be an acceptable solution. So now I'm going to go this way. And all the possible solutions to this system of linear inequalities is going to be anything in the shaded region that's shaded by both of them. So really, wherever it's a hashtag, hashtag math. So wherever it's that hashtag pattern, wherever you have both lines, that's going to be a possible solution. So really anything in here, and it will go on forever and ever and ever. But anything over here would be a possible solution to that system of linear inequalities. It's where they're both overlapping. And so a possible answer might be, I don't know, right here. Negative 3, 1. That's a possible answer. Negative 3, 1. That's a possible solution. You could do negative 2, 1. You could do negative 1, 1. You couldn't do negative 1, 0. Negative 1, 0 would work, yep. You could do anything over here. Any points would work. All of these points are all possible solutions to that system of linear inequalities. You could not do one over here because it's not shaded by the red line. You could not do one over here because it's not shaded by the blue line. So it would have to be shaded on both lines. Let's look at an example of how this would be used. So, come on, computer. Vámonos. Uh-oh. Issues. Hey, there it goes. Oh, awesome. Lou. Let's look at Lou. Lou is buying a macaroni salad and potato salad for a picnic. Macaroni salad costs $4 a pound, and potato salad costs $2 a pound. Lou would like to buy at least 6 pounds of salads and wants to spend no more than $20. So here are our inequalities. No more than, at least. We've got our inequality signs. So let's look at the dollars, because dollars are everything. Dollars are important. We've got $4 per pound of potato salad. Potato salad is Y, so it's 4Y, $4 for every pound of potato salad. And, oh, sorry, I apologize, $4 for every pound of macaroni, 4X. And then it's $2 per pound of potato salad, so plus 2Y. And we want to spend not exactly $20, but we want to spend no more than $20. So I can't spend above that. It's going to be less than or equal to $20. I could spend exactly 20, but no more than 20. That's the limit. That's a lot of potato salad. I also want to buy 6 pounds of it. Stomachache. Stomago. Lou would like to buy at least 6 pounds. So he wants to buy potato salad and macaroni salad. And he doesn't want to buy less than 6. At least 6 pounds means it'd be okay if I bought 500 pounds. Or 8 pounds maybe, or 12 pounds. But it has to be 6 pounds or more. At least 6 pounds, or it could be more. I've got a system of linear inequalities. That doesn't help me to graph much, though. I need to get y by itself for both of these. So if I'm going to graph both of these inequalities, I've got to get y by itself. So I'm going to subtract x from both sides. So y is greater than or equal to 6 minus x, which I'm going to write negative x plus 6. And I'm going to graph that. All right, on my line here, I have no scale really to work with. So I'm going to just go, I'll go by ones, I guess. 1, 2, 3, 4, 9, 10. You'll notice there's no negatives because you can't have negative potato salad. And we're not going to go in debt over this potato salad. And so we're just not going to worry about negatives. 5, 6, 7, 8, 9, 10. Negative potato salad. I have no idea what that would look like. All right. Y-intercept of 6. And a rise over run of negative x. So negative 1 over 1. Negative 1 over 1. I'm going to connect the dots here. And there we go. It would not go on to infinity. Because, again, you can't have infinite potato salad. And we can't have negative potato salad. So we're going to stop there. And then y is greater than or equal to, which means everything above the line would get shaded. So in terms of how much potato salad could you get, 7 pounds would be fine, 8 pounds, 10 pounds, 12 pounds, 500 billion pounds. Lots of potato salad. Now let's look at the other one, the blue one. I'm going to do a little bit of work down here, just so I can have some room. So 4x plus 2y is less than or equal to 20. You get y by itself. Subtract 4x from both sides. You get that 2y equals negative 4x plus 20. Divide everything by 2. And again, you can always slow this down and pause and help yourself keep up. Y is less than or equal to 2x plus 10. So y-intercept, 10. Slope, 2x. Negative 2x. That's why. There we go. I had the negative 4 over here. So it would be negative 2x plus 10. So I go down 2 over 1, down 2 over 1, down 2 over 1. Go. So I found the intersection point, but that's not really important for an inequality. There we go. I've got that. And it says that y is less than or equal to negative 2x plus 10. So everything down here. So we've graphed them. We've written a system of linear inequalities. We've graphed the solutions of that system. Now we got to list 2 possible combinations. Or a possible combination is going to be everywhere where both the blue and the red come together. So really anything in here is going to be a possible solution to this linear inequality. And there's an infinite number of answers. It's very hard to get this wrong because there are an infinite number of possible answers. I'm going to choose 1, 6 because that's a nice point. I like that point. So that's going to be 1, 6, which really, in terms of the problem, is going to be 1 pound of macaroni salad, 6 pounds of potato salad. So 1 mac, 6 potato. There we go. 1 mac, 2 potato. Sorry, 6 potatoes. Yeah, I could choose then 2, 5 maybe. There's another solution. You could choose 1, 7. There's lots of different answers. I'm going to use these ones. So I chose 2, 5, which would be 2 macs, and 5 potato salads. And that's how we get that solution here. How am I doing on time? 11 minutes. So this is what I'm going to have you do. I'm going to have you try this one on your own. I'm going to put the answers up, and then I'm going to have you try another one on your own, and we'll do it in class tomorrow. So try this one on your own. All right, I'm assuming you tried it. I'm assuming you did it on your own. I'm just going to reveal the answers, and then you can go and check the linked video on how to do this one. All right, so writing a system of linear equations. I've got x being the small boxes, y being the large boxes. There's my system of linear equations. If we are going to graph those two linear inequations where we have to get y by itself first, we should have a graph similar to this. Again, if you didn't, pause it, figure that out, or double check the linked video. I chose 2 possible solutions. There are lots of possible solutions. I chose 3, 4, and 7, 2. 3 small, 4 large, 7 small, 2 large. And if you didn't get those answers, make sure you watch the linked video. I'd like you to try this one on your own, and we will go through this in class tomorrow. Okay, good luck.